All right, so we are on learning objective 13, which is to calculate the number of representative particles or mass of a given number of moles. All right, so I'm going to use some different colors here to kind of signify different things. If I use blue, it's the quantity. If I use green, it's the conversion factor. And this like magenta color is the unit, okay? So the center of this guy is the mole, which is the amount of a substance. Its unit is the same thing. So it's mole, M-O-L is my unit, okay? It's my abbreviation for my unit. So then if I'm looking at the mole, I know that the mole is equal to, the molar mass. So I can get my quantity of mass through the molar mass. So my conversion factor is going to be the molar mass. My unit for mass is always the grams. Okay, so grams. All right. And then I have, so mole is equal to the molar mass in grams. So now if I want to get to my volume, the conversion factor that I need to get to go to my volume is my density, which is grams per milliliter here, right? That's my unit for density. And the quantity that I'm going to get into is my volume. And this is going to be usually in milliliters. Okay, so milliliters. Again, it depends on like what this unit of density is, right? So it depends on what the unit of density is. So I'm going to go through the density. This is the volume of a liquid. Or a solid. Okay, so liquid or solid there. Then I also know that the mole is equal to 22.4 liters. 22.4 liters of a gas. So again, this is a gas. And this is at STP. Okay. So then this quantity would be considered the volume. But instead of it being a liquid or solid, this has to be a gas. Okay. And this is in liters. So this is measured in liters, which is a capital L. Okay. I also know, so the mole is equal to three things. So molar mass, 22.4 liters of a gas at STP. And then it is also equal to Avogadro's number, which is 6.022 times 10 to the 23rd particles. Okay, so then this quantity is the particle, which can be either the atom, ion, formula unit, or the molecule. So molecule is for a molecular compound. Formula unit is for ionic compound. This can also be for molecular element. Okay. Ion is just for an ion. Atom is for just an atomic element. Okay. So ion is just an element within an ionic compound. Okay. So those are what all those things equal to. Now, if I am moving, so let's say I move going from volume to mass. So my volume, I've got a volume, I've got my mass. I'm going to multiply by the density. And if I'm going from mass to volume, I'm going to divide by the density. Okay. If I'm going from the mass to the mole, I'm going to divide by my molar mass. And if I'm going from the mole to the mass, I'm going to multiply by the molar mass. And it's the same thing here. So if I'm going out, I'm dividing, I'm multiplying. And if I'm going in to the mole, I'm dividing. So if I'm going from the mole to the particle, I'm going to multiply by this number. And if I'm going from the particle to the mole, I'm going to divide by that number. And it's the same thing here. So if I'm going out to the volume, I'm going to multiply by the 22.4 liters. And if I'm going down to the mole, I'm going to divide by the volume. Okay. Now, anytime that you have the divide sign, so divide sign, that means your number, your value, your number value is on the bottom. And anytime you're multiplying, that means your number value is on the top of the fraction. So like when I say top and bottom, I'm talking about the fraction itself. Okay. So a few things to remember. So the number one thing to remember is that your molar mass is based on the substance, okay, and must be calculated or found from the atomic mass on the periodic table. Okay, so they must be calculated or found. So I'm going to find them if they're elements. I'm going to calculate them if they're compounds. Okay, so let's look at an example here. Okay, so an example. How many moles are in 17.8 grams of carbon dioxide? Well, here's the first thing that I need to do here. I need to write down what I'm given and what I need, what I'm looking for. So my given and my unknown. Okay, so I am given 17.8 grams of carbon dioxide. Now, I need to write a formula for carbon dioxide, and I think you should know already that carbon dioxide is a molecular compound. So this guy's a molecular compound, right? And its formula is CO2. So then I'm going to put the number, the unit, and the substance. Now, I need to go from grams to moles. So I'm going from grams to moles. So now I go back up to my handy dandy little mole roadmap, and I'm at my mass. So I am right here. I'm at my mass, right? And I need to get to my mole, which is over here. So now if I'm going this way, I'm dividing. That means my molar mass for my substance is going to be on the bottom because I'm dividing, okay? So then I'm going to put times rho, and I got to get grams of CO2 on the bottom and 1 mole of CO2 on the top. Okay. Now, this value, I have to calculate that value. So I have to go to my periodic table and look up the mass of carbon and look up the mass of oxygen and then calculate that value. Okay, so I can go over here. I know that carbon, see, I have 1, and I'm going to multiply that by, so I'm going to find carbon on the periodic table. Carbon is 12.01, and oxygen is 16. So then I can come back over here and I can say, okay, carbon is definitely 12.01 plus oxygen, and I have 2 of those at 16. So then I can go and calculate those values. And that equals to be 44.01. So then this is equal to 44.01, which means that this is equal to 44.01. And then I can calculate this. So it's 17.8. So 17.8 divided by 44.01. Now, you can see that my grams of carbon dioxide are canceling and I'm in moles of carbon dioxide. So then I can go back to my calculator. So 17.8 divided by 44.01, and that equals out to be 0.045335333. Okay, now I need to look at my given value here and round it to the same number value. So like same amount of numbers. So I've got 1, 2, 3 sig figs. That means I need 1, 2, 3 sig figs in my answer. So 4.04 moles of CO2. Okay. So now, whenever you do a calculation and you have a substance, you need to make sure that you write that substance down. So I'm going to be looking for your number that you have, your sig figs, the correct number of sig figs, the unit, and the substance here. Okay. If I'm given 3.4 times 10 to the 21 formula units of cobalt-2 oxide, okay, my unknown here is how many moles. Moles is my unknown. So unknown given. So then I start with my given. I've got 3.4 times 10 to the 21 formula units. Now, this is cobalt-2 oxide, so it's a compound, so I'm going to have to write the formula for this. So I've got CO. I know that's a 2 charge, and oxygen also has a 2 minus charge. So this goes to COO. Okay, so COO times. Now, I'm going from formula units. This is a particle again. Okay, so I'm going to go through the 6.022 times 10 to the 23rd number. So 6.022 times 10 to the 23. This would be formula units of COO. And then on the top, I would have my 1 mole of COO. That equals out to be, again, here I'm dividing because I'm going into the mole. So if I'm going into the mole, I'm going to divide. If I'm going out of the mole, I'm going to multiply. Second, E. It's very important that you use this double E button to get your scientific notation. And that gives me 0.0056456459648. So I don't like having zeros in the front, so I'm going to put it into scientific notation. So scientific notation would be 5.6459 times 10 to the minus 1, 2, 3. So, and again, I need to look here to find out how many sig figs I have. So I've got 1, 2. So then I would have 5.6 times 10 to the minus 3 moles of COO. And this is what my unknown was. Here's my answer. So this was learning objective 13, which was to calculate the number of representative particles or mass for a given number of moles.